Alright, so in this problem, I have 8 to the power of x is equal to 16. So I want to find the value of x here. So for my solution, I'm going to start by rewriting my equation here. So my equation is 8 to the power of x is equal to 16. Now, before we start doing anything, let's just inspect this problem real quick. So if I plug in x equals 1 into this equation, I get 8 to the power of 1 is equal to 16, which 8 to the power of 1 is the same thing as 8, so I get 8 equals 16, which is false, right? Now if I plug in x equals 2, I get 8 to the power of 2 is equal to 16, and 8 to the power of 2 is 64. So I get 64 equals 16. And notice how there's a big gap between 8 and 64. So we know that the value of x is not going to be a whole number but a decimal, and it's going to be somewhere in between 1 and 2. So x is greater than 1 but less than 2. We know this. Now, how are we going to actually solve this problem and find the exact value of x? Well, what I can do is rewrite 16 as 8 times 2. Now what I'm going to do is divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to 2. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over a to the power of 1 is equal to a to the power of x minus 1, which is equal to 2. Now a is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x minus 1 is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1 is the same thing as 2 to the power of 3 times x minus 1. And 3 times x minus 1, I can distribute 3, so I get 2 to the power of 3x minus 3 is equal to 2. And 2 is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So this means that 3x minus 3 is equal to 1. And now if I add 3 on both sides, I get 3x is equal to 4, and x is equal to 4 over 3. Now, there actually is another way to solve this problem. What I can also do is at the start rewrite both of these in bases of 2. So 8 is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x, and 16 is the same thing as 2 to the power of 4. Now this is the same thing as 2 to the power of 3x is equal to 2 to the power of 4, meaning that 3x is equal to 4, and x is equal to 4 over 3. So this is a much simpler method of solving this problem. Alright, so in this problem, I have 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. So I want to find the value of x here. So for my solution, I'm going to first start by rewriting my equation. So my equation is 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. Now, to solve this, what I'm going to do is first factor out 2 to the power of 10 from my left-hand side. So if I factor out 2 to the power of 10, I get 2 to the power of 10 times, well, 2 to the power of 10 divided by 2 to the power of 10 is 1, so I get 2 to the power of 10 times 1 plus 1 is equal to 2 to the power of x. Now from here, 1 plus 1 is equal to 2, So I get 2 to the power of 10 times 2 is equal to 2 to the power of x. And a simpler way of doing this is, instead of just factoring this out, well, we have two 2 to the power of 10s here, and if anything added by itself is the same thing as that number times 2. So we could have just said 2 to the power of 10 times 2 at the beginning instead of factoring it out. So now from here, what I want to do is I can actually do this, solve this from here in two methods. So for method 1, I have 2 to the power of 10 times 2 is equal to 2 to the power of x. What I'm going to do is I'm going to rewrite 2 as 2 to the power of 1. And now if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So in this case, 2 to the power of 10 times 2 to the power of 1 is equal to 2 to the power of 10 plus 1, which is equal to 2 to the power of 11. So I get 2 to the power of 11 is equal to 2 to the power of x, and if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x is equal to 11. Now, method 2 of solving the problem from this step right here, so I have 2 to the power of 10 times 2 is equal to 2 to the power of x. Now, instead of multiplying 2, I'm going to divide 2 on both sides. So then these two cancel out, and I get 2 to the power of 10 is equal to 2 to the power of x over 2. Now 2 is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of x over 2 to the power of 1, that's going to equal 2 to the power of x minus 1. And now, again, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 10 is equal to x minus 1, or I could write this as x minus 1 is equal to 10. And now if I add 1 on both sides, these two cancel out, and I get x is equal to 10 plus 1, which is 11. So as you can see, these are the two methods, and method 1 is actually much simpler. It only took a couple of steps compared to method 2. And now the final step that we have to do, and we always have to do this in every equation, is to check our answer. So our equation was 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. We got x equals 11, so I get 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of 11. 2 to the power of 10 plus 2 to the power of 10 is the same thing as 2 times 2 to the power of 10. And 2 to the power of 1 times 2 to the power of 10 is the same thing as 2 to the power of 1 plus 10, which is equal to 2 to the power of 11.